So we gave you a little hint. Would you have done that anyway? We have a FOIL method. It's kind of the only algebra that you can do. Now, when you FOIL that, you end up canceling the positive and negative cosine, and then we end up with just 1 minus cosine squared. Does anybody have any questions on just kind of getting to that step? Okay, now there are two ways to go from here. Okay, but there's one way that would not be correct, and that would be to just cancel these cosine squareds. Now you're like, wait a minute, but they cancel. Well, I said just canceling them, okay, because you would have to use a heart method. You would have to take this cosine squared and put it to both. That's going to be the second option. I want to show you something that's actually a little bit slicker, and I'm trying to get you guys to the point that you're getting slick, you're getting sharp, you understand how to use these identities. 1 minus cosine squared. Okay, I don't know if you're seeing that in your sleep. I don't really expect you to be, but 1 minus cosine squared is an identity. So again, the more comfortable you get with this, you'll save yourself some aggravation. Are you looking in your book, or did you already notice 1 minus cosine squared? Now, eventually there'll be a point where I don't stand up here and say this, that you say, 1 minus cosine squared, that's equal to sine squared. Okay, now, again, this is kind of the slick way to do it because we're almost done. We have sine squared over cosine squared. Okay, and that's something that we've seen a few times now. That's in the same family as sine over cosine. So sine over cosine, sine squared over cosine squared. You know what's going to pop up here next? Tangent squared. Tangent squared. Now remember, even if you didn't get the answer, keep learning, keep growing, and maybe take a look at your heart method if you tried it. Okay, this tends to be what students see because they want to cancel those cosine squareds. Again, they do cancel, but it also has to go with the other part of the numerator. So we basically get a 1 over cosine squared, and we get a cosine squared over cosine squared. Okay, so 1 over cosine squared. If you want to go this way, 1 over cosine squared, the green one right there, is going to be the same as secant squared. And then the blue one, as you wanted to do, it cancels to be 1. What are you seeing here? I know more of you tried it this way. Do you have any questions on the green and the blue? That's an identity. Secant squared minus 1. It's an identity. If you look in your identity book, and of course this is the way this is supposed to work, it's going to equal the same thing. It's going to equal tangent squared. This is not an easy problem, all right? I won't say that every day, but it's just true. It's not easy, okay? It's a fraction. It's kind of the next level. Yesterday's lesson, yesterday's homework was kind of the next level. And as some of you were saying, you didn't have success with every problem, but sometimes we need to see it again. So what I'm going to do is go over each of these. I hope this isn't boring. I don't really have another way to maybe discuss this, unless you guys want to provide some of the input. Happy to hear your lovely voice. Factoring. It is a problem where if you don't factor, you're going to kind of go down a dead end. So we've got the sine squared, it repeats. You've heard me say that a couple times, but the more you see it, hopefully the more comfortable you get. So you factor out a sine squared. That means you're dividing it. That means you're left with a 1. Make sure that that first one gives you a 1. And then this guy leaves us still with tangent squared. I understand if you didn't factor it, it didn't look like this and it's probably not right, but you can change it. Again, it's going to be better for you to think about what I just underlined there. That means you're looking in your little book and you're seeing that 1 plus tangent squared is an identity. Again, look in your little book. It's secant squared. Secant squared. Just a little confession from the teacher. I get a little nervous. Do you guys, when I just say things like that equals secant squared, do you understand which identity I'm looking at? If you don't, please ask. Because again, I get a little nervous when I just say, hey, that equals secant squared. It's just an identity. It's a Pythagorean identity from the first day. Secant squared is the same as 1 over cosine squared. It's also the same as flipping. I'm trying to get you guys to understand this flipping idea. Here's the thing. If I flip secant squared, what happens is it ends up under sine squared. And it becomes a cosine squared. Now, I hope you're looking at what I showed here and realize that it's the same result. I either write it as 1 over cosine squared, and then it ends up in the bottom, or I can just flip it, and it ends up in the bottom. And that's how we get tangent squared. That's how we get tangent squared for that first one. Something that you want to comment on? Maybe, you tried it this way, you're not sure why it didn't work. Anything that we can help you here in the classroom. Sine plus cosine, cotangent. Now, it's not a factoring problem because there's nothing that's repeating. So what I got to kind of do is put something else into motion. I feel like the only thing I can put into motion is changing cotangent. Cotangent is ultimately a cosine over a sine. So we change it because there's really nothing else we can do. Now, it does make a fraction. And since we talked about fractions yesterday, we're kind of prepared to be thinking about the fraction skills that we're trying to develop. By the way, cosine that's in white times this fraction, that's the same as cosine over 1 times this fraction. What we're trying to say is that you want to be able to multiply the numerators. So cosine times cosine, this is one of those things where you definitely want to write this as cosine squared. This is a good problem. I know some of you didn't get it yesterday, last night, but sometimes you get some good vibes when you're sitting in A210. Are you getting any of those good vibes? What would you do here? What would you do? You're adding. How do you add fractions? You're adding. How do you add fractions? This would be from like yesterday's lesson. Common denominator. Okay, you need a common denominator. Now check this out. The only denominator is sine. So that by default has to be my common denominator. That means I need a sign down here. That should bug you a little bit though. I can't just put a sign down there without putting a sign up here. So we have to multiply top and bottom by sine. Again, are you getting any good vibes? I'm talking about sine times sine. Okay, now, when you start to catch on here, you'll realize that getting squares to show up in a problem is good, because when sine times sine gives me sine squared, and back up here when cosine times cosine gave me cosine squared, when I started getting those squares, good stuff happens, because squares often are Pythagorean identities. And this is the beauty, right? This is the beauty. Sine squared plus cosine squared is 1. Sine squared plus cosine squared is 1. And 1 over sine is cosecant. How we doing? Notice that the mini check is not today. I don't know if you were kind of like, probably going to be a mini check soon. It's tomorrow. So we're kind of giving you another day to process this. It's not a bad idea to redo some problems. Sometimes people think, well, I already saw the answer. Just cover it up. Just almost redo it. You'll start to get the feel for it. I know it's going to be the same problem, but you can even go back and you can do homework problems from 2 nights ago. You might not remember those. Did I copy this correctly? Is that sine over cosine tangent squared? Okay. Thank you. Thank you. Well. What do we have? First of all, I don't really want to change tangent squared to be sine squared over cosine squared. I don't want to put a fraction in a fraction. Do you understand? Tangent squared is sine squared over cosine squared, but I don't want to put a fraction in the denominator. Actually, kind of like the problem I did in the notes, I see sine over cosine. That's something that as you get more comfortable, you say sine over cosine is the same as tangent. Okay, now, when you see that, you can change it to tangent, but you have to understand that my tangent squared is still in the bottom. And by the way, the yellow tangent is technically over 1. Sometimes people aren't sure like where these go. So the yellow tangent is in the numerator. The tangent squared is still in the denominator. And then we get to a point that we can just do a little simple canceling. You can cancel. Now, after you cancel, you're still left with tangent in the bottom. Okay? I see sometimes kids want to like flip it to the top too soon. Well, now if you flip tangent to the top, it'll turn into its reciprocal. Or 1 over tangent is already cotangent. Again, you can think to yourself, flip it to the top and change it into cotangent, or you can just think 1 over is just equal to cotangent. All right. After we do number 4, just to kind of let you know, I do have another topic to teach you today, but it's easy. It's basically doing something with Desmos, and that's kind of on purpose because we're doing something hard, and I want to mix something in that everybody gets right. So we're going to kind of change gears because there's only so much of this you can take, in a 24-hour period. So we do have a little lesson, but let's talk about number 4. Kind of like number 2. We have to recognize that there's something that's being added. We have to recognize that there's a fraction. And what I'm basically getting at is we have to realize that this problem is going to require common denominators. So again, if you, it's kind of one of those things, if you don't go this way, it's going to be hard to get it right. So I understand if last night you didn't do this, but I need to think about this problem as common denominators. And again, that's because there's 2 fractions that are being added. Okay, so let's go down that path. Let's go down the common denominator path. Whatever's missing from this denominator needs to be inserted. Okay, but that means that I also need to put it in the numerator. Whatever's missing from this denominator needs to be inserted. But that means I have to also put it in the numerator. Okay, so here we are making the problem kind of get bigger. Yes, it's getting kind of bigger before it gets better. Here's where it starts to get better. When you start to multiply, you get squares. This would make a math student happy, because as soon as I multiply or distribute and I end up with these squares, okay, now first of all, sine times 1 is just sine. Okay, but sine times sine is sine squared, and cosine times cosine is cosine squared. By the way, just to save a step, this is already ready to be added together, so I don't need to write two fractions. I can add everything together. Basically, it's now one fraction. Okay, the numerators got added together. Now, for some of you that I spoke with when I checked your homework, I did have a typo in the answer key. I realized that at this point. But let's finish the problem. And again, the answer key was slightly off. Sine squared plus cosine squared. There it is. Sine squared plus cosine squared. Now that changes to the number 1. Okay, that changes to the number 1. I never showed you a problem like this where we ended up with a group, but take a look at the group that's in the numerator and the group that's in the denominator. Okay, I'm talking about the 1 plus sign and the 1 plus sign. These groups are the same. Since they're the same, and since this is a multiplication problem, okay, now since it's a multiplication problem, I'm allowed to cancel this entire group. Sometimes students are like, are you sure? You know, I thought you had to do a heart method. You don't have to do a heart method because the entire group is the same and it's being multiplied. Okay, so all of a sudden, a lot of the problem cancels out, leaves us with 1 over cosine. That 1 in the numerator is because everything divided to be 1. So 1 over cosine equals secant. Not secant squared, like I believe the answer key said. It's just secant. Now, if you're just kind of too shy to ask, but it's on your mind, that is the typical student question, are we going to have to be able to do this? Meaning like on a quiz or on a test. Eventually, yes. Okay, we're going to keep practicing it. Sometimes we look at number 4 and worry, yeah, that's a harder problem. Okay, could you see something like that? Maybe like once, maybe one more time on a test or quiz. But I do want you to start to catch on to some of these problems, which are a little more of a medium level. Okay.
We'll be allowed to use our identity book.
And you'll be able to use your identity book. So again, when it comes even time for the test, you actually will be able to have a little book open.
So when you I feel like the biggest problem is deciding what to do first, because once you get on the right path, it's pretty much just simplifying. Do you have anything because determining when to do take the fraction and multiply and stuff, how do you first determine where you should start?
Yeah, I'm tracking with you, and I don't know if I'm going to have a great answer except to say that we try to keep giving you experience. That means that sometimes you see me do it, then you see me do it again, and next time you see it, you start to say, okay, I can do the same thing. I have another good answer for you. There's an activity you guys will do with these next week, and I actually provide, it's almost like I read your mind, I provide the first step for almost all the problems. So it's just another step to try to get you guys closer. Okay, when you take a mini check tomorrow, you'll be able to look at your notes. So I would hope that you kind of can see examples that are similar. Eventually, when you take the test, that'll be the one time where, I'm not telling you what to do first. Okay, but we're gonna get there. I appreciate that, because that is exactly sort of the deal here. You do have to notice how to start these problems. All right, so keep coming back. What I'd like to do, though, is I'd like to change gears slightly, give us something, as I mentioned, that everyone can do. It's actually going to be something that uses Desmos. If you want to dig up Desmos, whether it's on a computer or on your phone, and let me give you the topic, because there'll be a couple notes that you'll take, but most of this is something on Desmos. We're in a chapter on identities. And there's a lot that we can do with them. Before break, we were doing some skills, which I'm not going to go back and review all those, but we did some skills that use numbers. So we did some problems that use numbers, and then we kind of got into what we just did on the homework. That's probably on your mind. But there's some other stuff that we can do with identities. There's actually kind of like a graphing skill. Okay, there's a graphing skill. What it really involves is trying to do what we call verifying. Now, when you verify something, you try to show that it's true. Okay, you try to show that it's true. What we're going to end up doing is verifying that something is true. And I'll also mention it's also possible that we could show that it's not true. Okay, so we actually have the possibility of something being true or not true. But basically, we're going to do that with a graph. Here's the method, and then I'll show you the problem. And the method is actually really simple, because the method just requires us to look at a left graph and a right graph. The method is really just to look at two graphs, a left graph and a right graph. If they are equal, make sure you see the equal sign, because sometimes people don't realize what I'm trying to say here. So if they're equal, well, it's almost common sense. All of you would have said, well, of course, if they're equal, then it's true. And of course, if it's not equal, as it says here, else, it would be false. Now, if you're saying, what's equal? Well, a graph, like literally the shape of the graph, like the look of the graph. I'm going to provide the example, but then we'll switch to Desmos to do most of the work. Okay, so take, for example, this statement. Sine over cosine equals tangent. Now, before we go any further, I kind of hope that you're saying, Mr. Naylor, that's true, right? Isn't sine over cosine equal to tangent? Yeah, it's equal. Okay, so we already know that the answer is true. You know, we've kind of established this as what's called the quotient identity. But I want to use this to help prove, or to not prove, but to show you guys what I mean by this graphing method. Okay, now with this graphing method, we basically have the ability to graph both sides of that equation, the left side and the right side. Just by the way, remember when using Desmos, sort of to mind your manners, I'm talking about changing the x-axis to go from negative 360 to 360. And then the y-axis, honestly, guys, the y-axis can kind of be whatever you want. Usually something like negative, I don't know, here they have negative 7.167. You can make the y-axis any negative to positive. Usually we keep it somewhere around negative 7. I think I've used negative 4. I'm just going to keep it with what the computer did. And then change it to degrees. What did I just do? I just graphed the left side of that equation. Okay, now that means I'm only graphing sine over cosine. Now I'm going to graph the right side of the equation. And you sort of have to be watching or have a good memory, because what do you notice? Well, you should notice that the right side is the same as the left side. We basically have two graphs that are the same. Now, sometimes people, this one's almost too easy that you don't get the idea, but the idea is that the two graphs are the same. And since they are the same, we've just verified that this is true. We've just verified that it's true. What's the answer? True. Okay, the answer would be true or yes. Let's sort of consider one more here. How about sine squared minus cosine squared equals -1? How about sine squared minus cosine squared equals -1? Now remember, what we're trying to figure out is if that's actually true. Does sine squared minus cosine squared equal -1? According to the graphing method, we can just graph the left side and the right side. Now, have you typed in stuff with squares on Desmos? You actually can use the caret top key. The caret top key is the button that's connected to the number 6. So I actually can type in a sine squared, just like it's written on the board. Make sure that you use the keyboard, or if you're using your phone, that you select the correct functions. And I'm happy to show you. Make sure you understand what's going on right now. Sine squared minus cosine squared is that red graph. It kind of looks like a sine wave. -1, or that is y equals -1, is that blue graph. Maybe you have some different colors because Desmos just likes to pick colors. But what do you think? Do the two graphs look the same? Does the wavy graph look the same as the horizontal line? Okay, I know it's almost too easy, but they're not the same. That's because this is not true. This is not equal. Now, if you have a good memory, you might remember a couple weeks ago that I actually said that this is a very common illegal. This is an illegal sort of student thought. Okay, so sine squared minus cosine squared is not equal to -1. Okay, because of some bad algebra. Try one. Here's one that I'm not sure if we know what the answer is. Like, that's kind of the idea. We're not supposed to know what the answer is ahead of time. It says tangent plus cotangent equals secant times cosecant. Tangent plus cotangent equals secant cosecant. Does the left side equal the right side? Nice thing about Desmos is you really can just type it in. It's doing a lot of good work for you. This is interesting. So something is going on here. I wasn't prepared for this. We're getting like a little exclamation mark, which kind of means like problem. Has anybody else gotten this, or have you been able to fix the problem?
I just put like around like.
Okay. Hey. Nice. Okay, so some parentheses. It looks like you just need to put them around secant, but it looks nice if you put around both of them. Make sure you're paying attention because, well, you should be seeing two graphs that look the same. Okay, obviously they're right on top of each other, but they indeed look the same. Okay, so we have a yes. I want to do one more. I know that we're kind of approaching the end here, but I want you to see something that, well, just a little fancier. Cotangent of x over 2 equals 2 cosine all over 1 plus 2 sine. What the heck is that? Okay, well, what we're really trying to figure out is, are both sides equal? And kind of thinking about what Sean just said there about parentheses, it's usually not a bad idea when you're doing a big fraction like this to already consider parentheses. Those yellow parentheses, I just kind of have a feeling that they would be a good idea whenever you're putting in fractions, especially that are a little more complicated. It's not a bad skill to learn how to input math equations, especially if you're using a keyboard. You're using parentheses, you're using the divided by sign, but you just kind of want to make sure that the way you're typing it in is the way that Desmos is interpreting it. It usually does a pretty good job. Again, those parentheses I suggested, you make a fraction. I wanted you to see one that looks like this. Okay, I want you to see one that it's kind of like, wait a minute, is that supposed to be the same? Well, if you typed it in correctly, it's saying what it's saying. They are not the same. They're similar, but they're not the same. One final thought. All the homework problems that you've done the last few days. You know what I'm going to say? All the homework problems that we did the last couple of days. If you typed them in, they would be the same. Okay? Because what you started with is supposed to equal what you ended with. So it's actually a way that you could check your work by checking if your two graphs really do come out the same. Okay, but for tonight, the problems are just for you to try with Desmos and see if the left is equal to the right. Okay, make sure you check out that homework helper.